All right, this is Josh Mandel with a little bit of a technical deep dive on transports in the model context protocol. And the short story is I would like to propose a new kind of transport, and I think it's one that would be suitable for a lot of consumer-facing applications that have privacy and security requirements to them. But first, just a couple of words of context. The model context protocol itself defines a message format that allows requests to be sent by a client and responses to be produced by a server, or vice versa. The client is generally the application that is hosting a set of tools, and the server represents the behavior of one of these tools. And this client and the server can communicate back and forth with these requests, responses, and notifications. And the protocol itself is sort of agnostic to the transport over which these things flow, but it comes with two built-in transport types, which have been standardized and included in the spec. And there's a little asterisk here because this user guide is a little bit out of date with the latest version of the spec. We'll get to that in a moment. But the first transport was essentially standard input and output, which is a great model if you are running an MCP server locally on your machine and you want to connect one application to another. The client simply launches the server as a process, binds to its standard input and output, and then can communicate back and forth using that as a channel. And this is based on the way that a lot of code editing tools work with the language server protocol that's been very popular and has become pretty widely supported across languages and across editing tools. And I think that's what inspired this design initially. And that works well, and this is included in many different tools, including Cursor, which is one that I use on a daily basis. It's also part of the Claude desktop application, has support for this transport. So very widely used, very robust for this scenario where a user wants to locally run their own tools. The other mode that is defined here, the other transport, was server-sent events, and the asterisk belongs on this one. This is morphed into something called Streamable HTTP by now, but they're both pretty similar. The idea is you might not have a local process running on your machine to connect to, but instead you're going to connect over HTTP to a remote server that has got sort of the data or the compute, and it's going to be able to respond with the relevant messages over the protocol. So the transport basically opens an HTTP connection, typically with some kind of streaming enabled so that you can see new results exactly the moment that they arrive, similar to standard I/O. And these are both good transport protocols. Right now, I think only the standard I/O is supported in Claude's desktop app, but Claude's web app is introducing support for MCP, which I presume is going to use either server send events or the streamable HTTP transport, which is replacing it. I don't yet subscribe to a tier of Claude access that supports those MCP connections. So with the plus tier, I guess I'm just still waiting to see when this shows up. But I think that at some point there will be the ability to connect your own MCP here, presumably using one of the web flows. Right now, I can only connect to a few services that Anthropic has decided would be sort of important partnerships to highlight in the context of the tools that they offer to me. But the real promise of MCP is that I can plug in whatever crazy long tail set of tools are going to help me do my job. And that brings us back to electronic health record access, which is what's got me pretty inspired in terms of MCP usage over the last month or two. And for electronic health record access, I showed a demo a couple weeks ago that used each of these protocols, transports, the SSE, as well as standard I/O. And I showed what it looked like to connect to a health record environment and then allow a language model to write queries against the electronic health record. But to make those work, if people want to follow along and try out what I built for that demo, they would have to go and download an NPM-based JavaScript tool that I had written, and then they'd have to execute it locally. And that requires a fair amount of trust. Maybe somebody would want to audit the code that I had written. Maybe they would want to make sure that it was following good practices, that didn't have security bugs and so forth. And that is itself undertaking a fair amount of risk. And running a server locally brings that. Or connecting remotely to an SSE or a streaming server also takes on the risk that suddenly your data needs to be available in that remote server. And that might not be a remote server that I trust as a consumer. So I'd like to make a proposal for a new kind of transport, which I would call the postMessage transport. And this is one that can run entirely locally in the user's web browser using web technologies. So the idea is my MCP client could open up a server just by opening up essentially an invisible iframe inside of the web page, and the client can talk to the server through that invisible iframe. And in that context, the invisible iframe can be holding on to data and can be performing computations then it returns the result of the computations back to the client. So I won't go into all the details of the proposed transport here, but I just want to point out there's an issue on GitHub. I would love to get reviews and feedback on this concept. There are certainly many details to work out, but I think it would be a pretty powerful addition. And to that end, I wanted to show just a quick demo, kind of pulling these pieces together from some of the tools that I had written back when I was originally writing a standard I/O type server. So this demo is going to use a version of the MCP inspector tool, which is an open source tool that lets you test out different MCPs. You could think about this as just kind of a developer's interface for how to kick the tires on a service. In the real world, you would use a client like Claude.ai or chat.openai.com or Cursor or other MCP-enabled clients to talk to these servers, but I'm going to use this sort of developer debugging-oriented tool. And so I added support for my new postMessage transport type here, and I'll show you the basic flow, where here I'm going to send it to mcp.fire.me/server/ehrmcp. And this looks a lot like a flow might look if I was going to connect over a streamable HTTP to a remote server. From the end user's perspective, it's not necessarily that different, but there is something very important here. This file that we're going to be loading is just a static HTML and JavaScript file. The data are not going to be stored on fire.me. They're not going to be visible to that remote server. Everything's going to be managed locally. So let's give it a shot and see how it works. Let me just clear out my state here so I can show you the demo from the very beginning. And let me actually clear out one more bit of state, which is the permissions that I've added so that we can see the full flow. So let's just restart. I'm going to say I'll add this provider. And inside, this is my iframe that my service is offering just to get things set up. This is kind of a one-time setup operation. And it's going to need to store some data. So it's going to ask for permission to do that. And I'm going to tell Chrome that, yes, I want to allow the internal iframe to be able to manage and store its own data here. And now I can either upload a record if I've already got it locally, or I could connect to a remote provider. So I'll just do that one. This is exactly the same as the kind of demo that I showed in a previous video, where I'm going to connect to my remote records. I'm going to authenticate. I'm going to choose a patient that I want to share. I'm going to go all the way to selecting which data types I want to share, and then I'm going to allow access. And what's happening now in this setup is that all my data are being downloaded locally into my local web browser, where they will stay. And they will become available to a MCP whose JavaScript code is running locally in my web browser. So now I have a new configuration called Joshua. That's my default configuration. And I am ready to actually test this out. So let me connect to this server. And in the MCP protocol, after a server initializes and advertises its capabilities, the client can query it and say, hey, what tools do you have? And in this case, there's a few, but the grep tool is the one for searching through the EHR. And this inspector tool will then read the definition of that grep tool and give me a little web form that I can use to fill out what terms I want to search for. So in this case, I'll just search for the word hypertension across my record. And we're going to get 50 matching results in one page in this case. And we can start to see medications, notes, and so forth that pertain to hypertension. So that's a quick demo of the workflow. But the idea is once the user has configured this postMessage-based MCP tool, it works just like any other set of tools. It works just using a custom transport. So this is something that is still very early kind of prototype. I built it out over the weekend, but I wanted to point out what I think are some of the security benefits to this kind of approach, where particularly for a consumer application, hosting the data together with the compute inside of a local iframe allows a kind of dissemination model that changes some of the risk profiles. And I'll certainly say that for me as an application developer, when I was putting this MCP together, I mean, yes, I do host the code as an open source GitHub repository if people want to try it out that way, but I would not be comfortable hosting a web-based version of this MCP server that was going to put patients' health data on a web server that I controlled. I just wouldn't be comfortable trying to offer that in a clean way. There's so many details to get right, and then it becomes a target for attacks. Very, very challenging. But as an open source developer, I am quite comfortable giving people tools that they can run locally on their own machine. And using the postMessage transport, they can run my tool without having to download anything. except through the web browser. And so the workflow really just becomes knowing the URL of the service that you want to connect to, and then getting access to that full set of data connection capabilities without having to actually allow your sensitive healthcare data to be transferred out to a cloud server. Of course, at the end of the day, with the MCP protocol, your sensitive healthcare data are making their way to a language model, but that's kind of the whole premise here, is that I want the help of language models like Claude or ChatGPT to be able to help me in making these clinical evaluations and decisions. So that's the quick pitch. I would love to get feedback on the GitHub issue, sort of working through some of the configuration and settings details here. And if folks are interested in building clients that support this kind of post-message transport, please reach out. I've built a couple of sample servers already that you might want to try connecting with. And I look forward to hearing everybody's thoughts.